Perfect. Thanks so much, Alyssa. Uh, Hello, everyone. It's so great to be speaking to you today. We have just a quick little project here, just examining some NCAA data, as Alyssa said, specifically looking to predict breakout seasons in NCAA Division I women's hockey. So just jump right into it. Some of you probably recognize this player. This is Jessie Comfer. She's a Boston University forward. Jessie, some of you may know her as also the best Comfer. Very important to get that in there. She had what I would say is a very respectable freshman season at BU. She was named to the Hockey East All-Rookie team. She had, I believe, the third most points on her team that year. But she basically really blew all of her stats out of the water as a sophomore. She finished third in the country in scoring. She was named to the Patty Kaz Memorial Award winner top 10 finalist list. She was also named a second team All-American. So just like a complete kind of jump ahead there for Jessie. Some of you who have been around sports long enough may be familiar with this kind of phrase from players that's common to hear in the preseason, that they're in the best shape of their lives. So this can be for sure an identifier of players who are ready to break out. But for some other players like Jessie, if they don't explicitly say that, we're just looking to figure out, what might have led them to break out. So in Jessie's case, what led her to break out as a sophomore? For sure, her talent is what actually, led her to have such an outstanding season. But really, we're trying to examine like which factors or stats might have existed already to tell us that she was indeed due for a breakout. The reason why this is important, I guess, for us is just, when you're trying to cover NCAA Division I women's hockey, there's, I think, 42 teams competing. So quite a few players to try to keep an eye on from year to year. And so just understanding like who might be due for breakout years is really important to knowing like which teams are going to be able to replace offense that's lost, which teams are on track to improve and be competitive. So that pretty much all leads us to our research question of how can we predict breakout seasons in NCAA Division I women's hockey. And we'll just jump into the data collection here.
Awesome. Yeah, so basically, as so many of you know, that the tricky thing with working with women's hockey is just, lack of available data, either whether it's accessible, whether it's even out there, all kinds of problems. And, it's the work of, people like all of you people that, kind of helps to bridge that gap. And so basically when we went about to try and answer this question, we kind of had to work instead of, working towards solving the question by finding data, we had to go kind of the opposite direction where we had to kind of solve our question around the data that we had. So, basically what we used most of was Dave McPherson's pick224.com. It's a fantastic website, where you can find all kinds of women's hockey related data. And that's where we kind of got most of our data. And then off of that, what we wanted to do was say, okay, how can we objectively define a breakout season? That's something that's not super obvious. And kind of what we settled on, after looking at, kind of our own subjective, anecdotes of things like Jessie Comfer and some other players, looking at seasons where we thought they broke out. We kind of looked at the data and saw that, we wanted to look at, adjust for, time of ice. We wanted to look at, okay, points, stuff like that. So we used Dave's primary points over estimated time on ice, basically E60. And that there's a whole formula that goes into that. You can go to his site if for more info on that. But basically, we define a breakout season as a season where that player increased their primary points over E60 by at least a half a point a game. So, but yeah, basically it's you're scoring a half a point more per game that you play over your previous season. And then also just our other data source that we used was College Hockey News. This is where you can find, shot attempt data or individual Corsi 4. And so unfortunately, just with what College Hockey News has on their site, we only had 3 seasons worth of data to go off of, the past 3 basically. At least for women's hockey, there's more available for men's. So that's another constraint we kind of had to work around. And then, finally, we just kind of merged it with the pick 224 data.
Okay, so now we have all this data. Now, what are we going to do with it? So we're coming back to an example of Jesse Comfort, who is someone we kept returning to as an example of someone we knew we thought we had a breakout season. So, like just mentioned, we decided to define a breakout season as over E60, an increase of 0.5. So if you click, we can see. So if we go ahead and click, we can just look at the differences between seasons and see, oh, breakout seasons in combo we can define as 2019 and 2021. But then we thought, in how we thought of a breakout season, that you really shouldn't be able to break out more than once. Otherwise, you're just racking up points you already have, but we already know you're still by that point. So then if we click, we can see we're just sort of ignoring any breakout seasons you might have after your first. So now we say, okay, Jesse had a breakout season in 2019. But that's not really the season we want to be looking at, because if we wanted to just know when they had a breakout season, we could just do this math we did here. What we're actually trying to predict is the season before the breakout season. So if you can click, we're actually trying to predict for 2018, is this season a pre-breakout season, or the season that comes before a breakout season based on metrics in that season. So that's what we're actually trying to predict right there, a season that comes before breakout season, which we call a pre-breakout season. So then there's one last issue. You might notice we sort of arbitrarily decided, oh, anything after your breakout season, after your first, doesn't count, which is fine. But then when trying to predict, we probably shouldn't include those stats, because those might have the same patterns for looking for a normal breakout season if someone broke out more than once. And also it doesn't make a whole lot of sense to try to predict more breakout seasons for a player who's already had a breakout season. So basically, we didn't include breakout seasons or any seasons that occurred after breakout seasons for a player in our data. Click. We just ignore those entirely. And that was how we got our data set. So now our model. So we decided to do a binary logistic regression because our dependent variable was binary. You either had a pre-breakout season or you didn't, and it's relatively simple to implement. So now going into more detail of the data itself, like you just said, we had 2 different data sets for our 2 different variables based on the data was available. You can see that they cover different year spans. So the first one covers about 6 years of potential breakout seasons. The other one covers about 2 years, because we can't use the first year for a breakout. The first year of recorded data can't have any breakout seasons based on how we defined it. And you can kind of see that matching with about a third of the data for the second data set in comparison to the first. Okay, so now our results. Spoiler alerts, they're not great. From 2015 and 2016, shot percent was a significant predictor, and that predictor was so significant, the pseudo R-squared value was 0.75%. I really wish I had like one of those like party favor blowouts, but I don't, because I didn't think that far ahead. But yeah, it's not great. Like for this sort of thing, humans are hard to predict, but even for like technology and other sort of vaguely comparables, you really are looking at something about like 20, like 30, 40%. So 0.75% is real low. And then if we look at the other data set, we actually find that both attempts and shot attempts weren't significant. The pseudo is sort of even low of 0.72. And you can sort of see, if we plot the data, that you can sort of tell that maybe the distributions between a pre-breakout season and not pre-breakout season might be different, but there's so much overlap, it's really hard to tell anything.
Okay, yeah, so just kind of wrapping up everything that Ann said. Basically, obviously we really didn't find a great model. That's kind of what we set out to do. And I know a lot of the presentations are going to be showing a lot of cool stuff that people are doing. And unfortunately for us, we just weren't able to arrive at the point that we wanted to. But I think what we did really successfully was kind of establish a framework for future work on this. Just things like, in that first regression where we had a lot of data, more data to work with, we saw that, luck factors like shot percentage can be valuable for trying to predict a breakout season. I mean, it's kind of intuitive, if you have really low shot percentage compared to the rest of the players in that season, you might be expected to, regress to the mean a little bit and have a breakout season the next season. So things like that, we think that, you can include in an actual model. And then, just kind of, next steps. I mean, obviously, you just need more data, and then also not just needing more, but it has to be easily accessible. I think that's something that it's nice. It would be nice to have, but it's either proprietary or it's, hidden, or it's something that's like on a PDF and you have to, manually input stuff yourself. So like easy accessible data is something that would go a really long way to, develop a working model for this. Some things that like we wish we could have included that we just weren't able to for reasons that, looking at team factors such as, primary points per 60 that are graduating from a team or leaving the team year by year. Obviously if, higher players are kind of leaving a team one year, you'd expect, players that didn't have, high numbers, their ice time might go up the next year because they're still on the team. And, that might be a factor to look at when trying to predict breakout seasons. Another one could be, we're looking at things like age curves and, what class they're in. I know Anne did kind of looked at it a lot, when she was doing, a lot of her modeling work. And, we didn't really have, I think, the sample size to kind of make conclusions off of that. But that might be something that with, just more data and more seasons available, that might be something that you can find trends in. And then the final thing is just, defensive data. We worked with primary points over E60, and we only really looked at forwards. We actually filtered out defenders out of our analysis. But, it comes down to the questions like, okay, can a defender have a breakout season? And, I think they can, but you have to judge it off a different metric, I think, just because defenders inherently just don't have a lot, quantifiable counting stats that are easily available to look at. So things like that, just to kind of, as a wish list to kind of add to our model to bring it to the point where we're able to actually predict breakout seasons to the level that, we think we could. So yeah, that's kind of wraps up our project.
And I just wanted to say a quick thank you to my wonderful group mates for their hard work on this, as well as to our conference organizers who are doing such a great job today, and of course to everyone else for listening and tuning in.
Thank you. It was really lovely. I think, definitely people in chat have been echoing this, and you guys will be able to see it when you kind of go back into Twitch. Just how much, like, sometimes in women's hockey you try stuff and it doesn't work out. Like, I was definitely talking with Carly this morning about, like, the number of like half-started projects I have that I started but like never finished, and how sometimes it's actually really useful to get that half-finished work out in the public, because then people can build off it rather than people then having to build the same semi-broken thing that you broke several times over. So it's been lovely having you all. If you have any questions for these guys, hit them up on Twitter, find them in the Twitch chat. They are all fantastic and lovely, but we are on to the next talk. So again, we'll be back in a moment.